This question related to electricity, the electric circuits mainly. We did question 1, now question 2. And the answer key is also there. So figure 8.1 shows 3 lamps are connected and a fuse, 3 lamps and a fuse connected to a power supply. So there's a 220 volt supply, a fuse is there, and 3 lamps are connected. How these lamps are connected, in series or parallel to each other? How they're connected? Is it a series combination or a parallel combination?
Parallel.
So it's a parallel combination. And what is the characteristic of a parallel combination? The supply voltage, if only the one component, like all are in parallel, so the voltage will be same. If it's a 220 volts, so they all will have the same 220 volts. The voltage will be same, but the current will divide between them. Like the total current, if I say a total current is I, then it will be I1 here, this will be I2 here, and this will be I3 here. So the total current will divide between them, but the voltage they all receive or they all have the same voltage. That is a characteristic of a parallel circuit. In the question, the electromotive force, the EMF, means when the chemical energy converted into electrical energy. Each charge carry 220 joule, that's called EMF. Each lamp has is labeled 220 and the power is 40. The rating of a fuse is 2 ampere. Like rating of a fuse 2 ampere means maximum it can allow 2 ampere. We have to calculate the current in each lamp. So we have the power of the lamp, which is 40 watts, and we have the voltage, which is 220 volts. Which formula we can use to relate the power, voltage, and current, as we need the current? So we have the formula power equals to voltage multiplied by current, or P equals VI. The power is 40, so we write here 40. The voltage is 220, and the current we don't know. So we need the current, so it will be 40 divided by 220. What is 40 divided by 220? How much current will flow in each lamp? 40 divided by 220. What is the current?
0.18.
So there is a 0.18. So there will be 0.18 ampere. And these all lamps are identical and they all have the same power. So 0.18 ampere in the first lamp, there will be 0.18 ampere in the second lamp, and there will be 0.18 ampere in the third lamp. So each lamp will have the same 0.18 ampere because these all lamps are identical. And we know the power and the voltage across each lamp. So the first part, the current in each lamp, whenever you have a case, like you have to write a formula. So that's why 0.18 ampere, and 1 mark is for the writing a formula or substituting the values in the formula. Calculate the current in the fuse. So how much current will flow through a fuse? If there was a current of 0.18 in the lamp, first lamp, the current of 0.18 amperes in the second lamp, and the current of 0.18 ampere in the third lamp. So how much current is from the passing through the fuse or from the supply? So as you can see, like the total current divide in the branches. So what will be this current? It will be 3, because there are 3 lamps, 3 branches are there, each is 0.12. So total will be each is 0.18. So total will be 0.18 times 3. That will give us a total current in the fuse or from the supply. So 0.18 multiplied by 3, what's the answer?
0.54.
It means 0.54 ampere is the current which entered the circuit from the supply, and that 0.18 will flow through the first lamp, remaining 0.18 to the second, and the 0.18 to the third. So that's why the total current which flow through the fuse or from the supply, it's 0.54 ampere. And the next part, the total number of the lamps which we can connect in parallel without blowing the fuse. fuse can, because the fuse, as I mentioned, it have a rating of 2 ampere, means maximum it can allow 2 ampere to flow. If the current is more than 2, the fuse will not allow. So the question is, how many lamps, more lamps can be connected, the identical lamp, so that the fuse does not blow. So how we can work out this? We want
So it will be
the total we need 2, maximum 2.
2 divided 0.18.
And current in each lamp is 0.18. So we'll know how many lamps will be there. So 2 divided by 0.18. What's the answer?
11.1.
So 11.1, but lamps cannot be like 0.1 or 2. So lamp can be either 11 or 12. So how many lamps we can connect in parallel? So we don't say 11.1, we'll say 11 lamps, because there's no 11.1 lamp or 11.2. So 11 lamps can be connected in parallel before this fuse will blow. The last part, after a long period of use, the wire of a filament of one of the lamp become thinner. Underline the effect of this change on the resistance of a filament. How the area affect the resistance? It will increase, decrease, or stay same. You can use the screen annotation to circle. So the resistance will increase because resistance is inversely proportional to area. State and explain that effect of this change on the power. So how the power of the lamp is affected as the resistance increase. Look, when lamps are connected in power is having a 3 formulas. P is equals to VI, P is equals to V square over R, or P is equals to I square R. This is how the power is related. So what happened? Because the resistance of the lamp is increasing, so what happened to the current? The current will decrease. Voltage is same because they are connected in parallel. Voltage does not change. So if the current is decreased, as the resistance increase, the current will decrease. And as the current will decrease, the power of the lamp will also decrease. So answer here, you don't have to use the other 2 formulas to explain. You simply mention that power is a product of voltage and current. Voltage is same as they are in parallel. So as the resistance increases, the current decreases. When the current decreases, the power will also decrease.